Hello, friends. It's Uncle Sam again. And previously, we talked about how to use exactness of an equation, how to find if your equation is exact, and how to use your integrating factor. And so now we want to solve questions and see how to actually use them. It's a kind of steps you need to follow through to get your answers. Okay, so let's move. Um, so the first question we'll be solving here. Let's say two. Sorry. We have 2xy plus y squared dx plus x squared plus 2xy dy equals 0. So hopefully you still remember the steps you need to go through. Do you remember that we had to say when you have mx comma y, okay, let me divide this into 2, mx comma y dx plus n as a function of x and y dy equals 0. You need to look for the m dy. If it is equal to the n dx, then it means it is exact. So this is how to verify. And so we have to go through the same thing here. So let us have this as m, right? And let us call this n. The m dy, if you go to this equation, you want to differentiate 2xy, right? Then your differentiation will give you 2x because it's more of like a partial derivative. So this will change to constant, so you have 2x left. Then plus 2y. If you're trying to differentiate this, 2 will go forward, then subtract 1 from the power, you have 2y. So that is, so let us kind of box this partially. Then let's find the n, the x. You want to differentiate this with respect to x, right? So with respect to x, you have 2x, right? Plus this with respect to x, this will change to 1, right? And you have y left. So that's 2y. So if you check both the m dy and the n dx, you can notice that it's the same. So the m dy equals what? The n dx. So that means what? It is exact. If these two are exact, you need to solve for the equation. And the steps you need to follow is you need to pick a function that connects m and n, and that's u, which is what? M. No, let me start from um okay, I'm coming please. Let me Okay, so you have the u, the x to be your m, and you also have your du dy to be your n. So this is where you're going to start solving after your exactness. So you have this here. Then you can say from here, bringing this out, you can say du equals what? M dx. So bring in m, which is this, right? Um, you have du equals 2xy plus y squared, then dx. If you want to get your u, so we're interested in getting u from here. If you want to get u, then you need to integrate all through. So u equals what? Integral 2xy plus y squared dx. So then we're supposed to have a constant. Our constant is going to be, since we are integrating with respect to x, then it's going to be function of y, since we are dealing with partial derivative. So because this is partial derivative, what we have is going to be function of y. It's not going to be function of x because this is going to be covered by the x function. And so the constant you have is going to be your f function of, let me just say function of y. So u now equals what? You want to integrate with respect to x. So you have 2, then you have x squared over 2, then multiplied by y. Then plus, if you want to integrate this with respect to x, you just need to add x to it because your y squared will definitely stay. So you have x y squared plus f as a function of, then plus f as a function of y. 2 we cancel 2 here. So you have u as x squared y plus xy squared plus function of y. Then, okay, let's also square this partially. Let's box this partially rather. We've used this, right? This du dx equals m. That's how we're able to get this. Then we need to go back to this and also use this. So let me write out our value for u. U equals what? X squared y plus what? Xy squared plus function of what? Y. And our du dy is n, right? So that's what we want to use next, which is what? What's our value for n? This is n. X squared plus 2xy. X squared plus 2xy. Then since we have value of u, you're going to bring in this value. So it's like you're replacing this u with this value of u. So you have x squared y plus xy squared plus f prime. No, sorry. You have xy equals what? N, which is this x squared plus 2xy. Then let's differentiate this with respect to y. So you have x squared plus what? Then you have 2xy plus f. So if you differentiate this with respect to y, you're going to have f prime function of y, right? Equals x squared plus 2xy. So you have this, we cancel this, right? This, we also cancel this. So you have fx prime y, f prime y equals what? 0. Then f as a function of y, you need to integrate this for u of 0 for you to get what? So if you integrate this, you're going to get a constant, right? Let's call this c. So this value here is what you're going to put into this equation. Since you need to find f of y here. So you have u equals what? X squared y plus xy squared plus c. And also, you need to remember that the u equals 0. Therefore, u itself is going to be a constant. Therefore, x squared y plus xy squared equals what? C. X squared y plus xy squared equals what? C. Yeah, that's it on how to find your exact ODE. Hope you like this. Thank you.